Continuing on in section 6.7, in a one-to-one function, each x value corresponds to exactly one y value, and each y value corresponds to exactly one x value. In one-to-one functions, both the relation and its inverse are functions. Take note here, composition of inverse functions on page 408. If f and f's inverse are inverse functions, then if we take our inverse of our function of f of x, we're going to get x. And if we take f of our inverse of f of x, we're going to get x, as long as x is in the domain of f and its inverse. So in example 6, we're going to find each of the following for f of x. First thing we're going to find is the inverse. So again, remember that this is kind of like a y. So our first step is going to be to swap our x's and our y's. So I'm going to have x equals 1 over y to the negative first power. I'm going to solve for y. First thing I'm going to do is get rid of my fraction. So I'm going to multiply by y minus 1 on both sides. Y minus 1 times x equals 1. Now, we're not going to distribute here because I'm trying to get y by itself. I'm going to divide to get rid of my x. So I'm going to have y minus 1 equals 1 over x and add 1. So y equals 1 over x plus 1, or my inverse of x equals 1 over x plus 1. My inverse of f, sorry. Now it wants me to find f of my inverse of f of 1, which means we're going to plug 1 into our inverse. Whatever we get for that, we will plug into f. We have a composite function here. So I'm going to plug 1 in my inverse. Okay, 1 divided by 1 is 1, plus 1 gives me 2. Now I take that value, and again, I plug it into my original function. So I take f of 2 equals 1 over 2 minus 1, and I get 1. So my composite function here of f and its inverse equals 1, which according to our property that we just talked about in the take note on page 408, that's what we should get. When we take with one-to-one functions, f of our inverse of a value, we get the value. Or if we take an inverse of f of the value, we should get that input as well. So here in C, if I can find it, we're going to do the same thing. We're going to plug 1 into f. I get 1 divided by 0, which we can't do. So here, this doesn't exist. Because 1 is not in the domain of f, if I go back up here and look at f of x, I can't have division by 0. So x minus 1 cannot equal 0. X cannot equal 1. So to plug it in to f of x, that gives me a problem. In my inverse function, I have division by 0 here. So x cannot equal 0 there. So here, if I'd have tried to plug in a 0 first, we'd have had no solution as well. It does not exist because 0 is not in its domain. Also, if what I would have gotten for f of x would have been a 1, or for my inverse would have been a 1 here, it wouldn't have worked to plug in to my function here as well. So we still have to calculate just to make sure that we don't have anything like this happening. But it at least gives us a starting place and a way to check at the end. As long as our values along the way are in our domains, we should output our input. What is each of the following? Feel free to pause here and give this a try if you'd like. First thing we need to find is our inverse. And remember, g of x is just like our y. So when I swap my x and my y, everything else in my equation stays the same. Now, I'm going to solve for y. I'm going to get rid of my fraction by clearing my denominator. I'm going to get rid of my multiplication by dividing. I'm going to get rid of my addition by subtraction. Another way I can write this is my inverse function there. Inverse of g. Now, I'm going to find g of my inverse of g of 0. And when I try to do this, I'm going to plug 0 into my inverse. And when I do that, I get division by 0. 0 here is not in my domain of my inverse. So here, this does not exist. Now, for c, I'm going to plug 0 into my function. And again, my function for g was this. So when I plug 0 in for g, I get 4 over 2, or 2. And that 2, I plug into my inverse. My inverse is 4 over x minus 2. So when I take that 2 and plug it in, I get 2 minus 2, or 0, which, as long as all my values along the way are in my domains, which here they were, is what I should get. So we are good to go there. Quick recap here for section 6.7. The inverse of a function may or may not be a function. When we square each side of an equation, the resulting equation may have more solutions than the original equation. And we saw that when we squared our square root function, when we found the inverse of that, and it looked like we'd have the whole parabola, but according to our domain and range, we only had half. If f and its inverse are functions, and if either maps a to b, then the other maps b to a. The range of the relation is the domain of the inverse, and the domain of the relation is the range of its inverse. And that's all I have for section 6.7.